Good morning or afternoon, everyone, depending on where you're at. Welcome to the webinar. My name is Ryan Fragapane. I'm with AASHTO. I'm going to give it about another minute here for everyone to trickle in. We still got people joining us, and then once everyone's here, we'll go through some housekeeping items, and then we'll go ahead and get started. But welcome, everybody. All right, everyone. I have about a minute past the hour, so we will go ahead and get started. Like I mentioned before, my name's Ryan Fragapane. I'm one of the product directors at AASHTOware, and welcome to the webinar. Thank you for attending. I think it's going to be a great webinar. Special thank you to Wisconsin DOT for all the effort they put in to put this webinar on. So I really appreciate it. We're going to introduce them in a second, but I did want to go through a little bit of housekeeping before we go ahead and get started. As you're joining the webinar, you'll notice that you're muted. The reason for that is we're going to be recording the webinar. So we have a clean recording for everybody. We're going to keep everyone muted throughout the webinar today. However, we still encourage you to be engaged and ask questions. So at the bottom of the screen, there should be a Q&A box. If you click there, you can type your questions in. Feel free to type them in throughout the presentation. We'll answer some during. We might even hold some and answer them at the end, depending on where we think it's the best time to answer those questions. But as you think of them, please don't hesitate to put them in the Q&A box. From there, we will be issuing the recording after the meeting. So give me about a day or two after. We'll get the recording cleaned up and we'll get it posted to YouTube. And if you registered for the meeting, you'll receive a link where you can download or watch the webinar. So with that, thanks for attending, and I'll hand it over to Greg with Numetric.
Awesome. Thanks, Ryan. Before we get started, just one kind of high-level announcement. Let me go back a slide. We do have, at the beginning of our last webinar, we talked about the upcoming AASHTOware Safety User Experience Committee meeting. We do have a time scheduled for this year's 2024 User Experience Committee meeting. It is going to be in Kalispell, Montana, and the dates for that are September 10th through the 11th. You should receive a registration email for that if you received the email notification informing you about this webinar. So if you're interested in registering for that, we'd love to have you attend. It's a great meeting. Every year it seems to be just getting bigger and better. So looking forward to meeting with everyone this September. So look for that invite coming up. All right, we are really excited today for our webinar. As I'm sure you know, the topic that we're going to be taking a look at today is incorporating the Highway Safety Manual, specifically focusing on Part C in the design process. We are really excited to have our presenters with us today. Just by way of kind of agenda and what we're going to be covering in the webinar today, I'm going to go through some introductions really quick and make sure that we introduce our presenters. We're then going to hear from the Wisconsin DOT representatives we've got with us today, who will be sharing the bulk of our presentation. And then we do have, for the second part of our webinar today, a preview of the AASHTOware Safety Alternative Design Part C application for designers. So Danny Anderson will be sharing a little bit about that with us at the end of our webinar. And then we always do like to keep a few minutes at the end reserved for Q&A. So as Ryan mentioned, feel free, and in fact, it's really quite helpful to ask those questions in that Q&A window real time as we're kind of going through the webinar. That way you don't have to kind of remember the question you were going to ask. Go ahead and just drop it in the Q&A window as you think of it. And chances are we'll probably circle back and answer all of those at the end. But there may be some questions that we actually answer real time during the presentation. So we'll keep an eye monitoring that Q&A window, and we may also respond back with just a message answering your question as well. So keep an eye on that as we go throughout the webinar today. But let's do our introductions really quick. So we are very excited to have with us today Dan Brugman and Kevin Scopeline from the Wisconsin Department of Transportation. They are both, they've been working really hard in Wisconsin for quite a while now, specifically focusing on the HSM Part-C as they're looking at the incorporating that in the design process. So they've got some great information. We've had some great conversations with them, and we're really looking forward to what they're going to share with us today. And then I'm Greg Olson with Numetric, and we also have Danny Anderson, our Vice President of Product, with us here at Numetric, who's going to be presenting at the end. But we will go ahead now and actually kick it over to Dan and Kevin with the Wisconsin DOT, and they're going to take over the presentation from here, and then we'll circle back and wrap up once they're done. So Dan, Kevin, take it away.
Sure. Do I have my screen shared now?
Yep, coming through great.
Great. Yeah, so my name's Dan Brugman. I'm one of the state safety engineers for the Wisconsin DOT. Kevin and I are here today to talk about how we've incorporated the Highway Safety Manual into our processes. Just a brief agenda, just to talk a little bit through our background on where we came from and where we are today. Where does it actually fit within our project processes? A little bit on our network screening and alternative analysis, and then some of the challenges and successes that we've had. This slide's just for reference. Should Kevin or I, just like every state DOT, we like to use acronyms and abbreviations. These are just common HSM terms. But just if we slip up and use one of these, just refer back to this slide if you look at this after the fact. So a little bit on our background. Wisconsin historically relied very heavily on engineering experience to help identify and diagnose safety issues. The philosophy was to apply standards everywhere, which is referred to as nominal safety, regardless of whether or not there was a safety issue or an operational problem. Just kind of walking through the three big steps. Network screening, we largely use crash rates for identification, engineering judgment, and most importantly, public feedback. Diagnosis, we relied very heavily on our experienced engineers to look into those issues. We had a couple tools, like for intersections, we had our ICE process, but we really relied on that judgment by looking through things like crash diagrams. Alternative analysis was more or less just applying our design standards on all of our roadways. The phrase that was used often was design exceptions were very rare. We did on occasion use tools such as CMFs or estimates to help estimate effectiveness of countermeasures. The next three slides have a ton of information, and hopefully I don't read all of it, but what the main thing I want to get across here is that this process didn't happen overnight. There were a lot of challenges, and it took a lot of collaboration over the years. We learned a lot of good lessons, and we're still facing some of those challenges and taking those baby steps to try to get our process more refined and more reliable. But when the HSM first edition came out in 2010, it took a couple years of the safety engineering program to investigate this. There were a lot of the implementation issues, struggles with getting the buy-in. However, in 2016, there was a separate effort department-wide. There was an emphasis and shift towards applying performance-based practical design across the board. So this had a lot of emphasis on using our data to make more informed decisions, and the reliance on using actual research and tools to quantify benefits to make those decisions. So this tied very, very well with the HSM. So we were able to work with that group and create what we call the safety certification process, which is our version of that highway safety manual adoption. And this process aligns with the road safety management process, which is outlined in that HSM. So when this first came out, we started using, for our screening process, we just continued using crash rates. However, in 2019, we had a project to go through inventory all of our intersections. We created network screening SPFs for screening of intersections. We also took those HSM intersection models and calibrated them to our local Wisconsin conditions. The next year in 2020, we realized that some of our vulnerable road user issues were being overlooked in our screening process. So we added some criteria to help ensure that those crashes were being investigated. A couple other tweaks that we've made was just renaming stuff to align with that road safety management process. One of the bigger ones that we made was requiring a cost estimate for our no build scenario, because often we were just saying we're going to do that improvement anyway. So there's a big difference between a thin mill and overlay on a road at an intersection, for example, compared to a pavement replacement. So some of our alternatives that add on costs was not helping our benefit cost situation. 2022, another challenge that we had was how do you deal with operations? So we had a safety process that quantified everything. So we created this operational certification process, which uses the safety process to help supplement that. So this process is mainly when safety isn't the driving force of the reason we're looking at that, or maybe when it was evaluated through our safety process, it didn't quite hit that threshold that we set, so they can kind of supplement the operational benefits in that. Most recently, we worked on getting our segment models calibrated for alternative analysis, and we also created network screening SPFs for our segments. So some of the future updates that we're going through right now is figuring out how do we implement these and where are they going to work. Another big one is we use IHSDM for alternative analysis, and that's sunset. And then just the big thing that's going to be the ongoing and maintenance of all of these tools and calibration factors. So where does safety fit within our improvement program process? Well, it's required. Our safety process is actually done within scoping within our project delivery process. There's only a few exceptions where it isn't required, such as maintenance projects or emergency projects, like if a bridge gets hit, or projects that the intent is to just provide as minimal pavement improvement as we can, such as like crack filling or patching. The other exception is where we have expansion projects, which we call modernization, where we're building those new roadways to current design standards. So it's really focusing on the majority of our program where we're just doing resurfacing and rehab work. This graphic illustrates our delivery process. Our process occurs within the scoping phase or the conceptual design phase. So after a project's loaded, the safety process is completed and incorporated into our final scoping documentation. So the discussions around safety are ongoing throughout this process. They can extend into the design phase depending on public input or things that happen throughout the natural life cycle of a project. For example, if the pavement treatment isn't quite figured out within scoping, later on it gets determined that instead of doing a mill and overlay, we're doing like a profile raise. And what's the nice thing with incorporating it into scoping is now everything's kind of geared around that safety discussion. So like when that happens, we often start talking about, well, now that we're raising that profile, we're not really going to extend our roadway because we're in a very much a preservation mode. So we get conversations going about, well, what are the impacts to the shoulder if we sacrifice some of that due to that profile being raised? So there's a lot of those conversations and decisions being had involving our process. So the advantages of having it in our scoping process is it ensures that safety needs are identified very early and are actually being incorporated into projects. So it helps with that purpose and need. It identifies the locations that are actually safety issues with the highest potential for improvements to make use of our limited funding. And it provides a consistent application of analysis statewide, which assists with making sure that we're actually appropriately using countermeasures and applying them consistently across the state. So one region makes a decision, the other region would have the similar decision. Little brief topic on our discussion on our network screening here. Within our network screening, we try to target 10 to 20% of the state highway system for further investigation. It's important to stress that not all of this actually leads to improvements. It's pretty much a smaller chunk of that. But the idea is that we try to target a manageable level that is not performing well so that we can investigate those for improvements to, again, make better use of our limited funding. So our screening process identifies segments and intersections. We refer to these as safety sites of promise. We actually have chosen to use the level of service of safety for our network screening metric. We currently use this for intersections, but if you recall earlier, we're still working on getting our segments to use this methodology. We're still using critical crash rate method, or we refer to it as the statewide crash rates for segments. But we're moving towards the level of service of safety or loss. The graphic on this page helps to illustrate how the loss groupings are determined. So that solid red line on this graph is the safety performance function prediction for an average location given the site-specific context. So for example, if we have all of our rural four-leg two-way stop control intersections, this chart would have a bunch of dots all over the graph, and that SPF would predict where our crashes are, and anything above that line, so the LOSS 4 and LOSS 3 are performing worse than predicted, worse than their peers, and then anything below is actually performing better. So WSDOT has actually focused on targeting those lost 4 locations because they're experiencing significantly more crashes and it has the greatest potential for improvement. We can adjust these breakpoints for all of our loss categories with a gamma distribution. So we try to keep that 10 to 20% target when we update our tools. So the 2 screening metrics that we have are, we look at it in 2 different ways. We flag things, as we call it, for total crashes, which includes all crashes, property damage, and injury. And we also just look at it through an injury lens, just all of the injuries. The next step after our locations are identified, we diagnose the location. So what we do is our region safety engineers review crash data for all of those sites of promise and try to identify any treatable crashes or trends that may exist and the underlying contributing factors that are causing those crashes. This step removes crashes that we can't solve with an engineering solution, which we can try to maybe solve other ways through behavioral, but we throw out crashes that don't have an engineering solution, such as equipment failures or like couches flying off cars, and animal crashes is another one. So I will turn it over to Kevin to talk through our alternative analysis.
Thanks, Dan. So as Dan kind of mentioned, walked through how we kind of get to a location that had some experiences for higher than average crashes, came up with some potential solutions. Well, now we need to go ahead and evaluate and kind of determine which one of those solutions is our preferred, which one we want to move forward with. So our goal with this is to quantify the safety impact or benefit of the different alternatives that we're considering. Right now, we're using a benefit cost ratio, so a BC value, as our main metric for determining what that looks like. And as it's up on screen, it requires a lot of data. The network screening SPFs that Dan walked through earlier, that's really our required data. That's the baseline. Honestly, it's also a lot of the Meyer FDE that the feds are going to be requiring in a couple of years here. So that data should hopefully be accessible to everybody moving forward. It's really the model dependent data where things get a little bit more complicated. Each model is built differently. Each model requires a different level of detail. Knowing which model requires different bits and pieces of information and knowing whether or not that piece of information is going to significantly impact the outcome is not easy to know in the beginning. It's something that we've had to learn along the way, and we've spent a lot of time educating the folks doing our analysis. So it's something that's always kind of a work in progress, and anytime somebody picks it up, there's a learning curve to it. Some of the things that, Dan, if you want to go to the next slide, some of the assumptions that we use within our analysis process is we want a consistent approach to our analysis period. So we picked a 10-year analysis period, and I'll likely touch on that later on in our challenges and successes. But one of the other things that we found to be beneficial is limiting the number of crash modification factors to a maximum of 2 per location that we're looking at. This is due to not a lot of research in this area in terms of the interactions of when multiple CMFs are combined to get an overall effect. There is some work, I believe, coming out at the HSM2. So we'll see how that changes and impacts our methodology and analysis. But for right now, these CMFs are the ones that are, we call them external. So they're not what the HSM2 is going to call adjustment factors. These are metrics, or I would say other countermeasures that are outside of those baseline alternative analysis SPFs. I think this is a point of confusion that we had with our engineers as we went through it. We use the term SPF very frequently, a safety performance function. And there's a couple of different types. Again, Dan walked through the network screening ones, and then there are the alternative analysis ones, and that's the Part-C, which we're going through now. And when we can, we want to use those SPFs. So we have 3 different methods. They're related to, I guess, the reliability traditionally or typically associated with the outcome. So our method 1 analysis is usually the least reliable. Not always the case, but often is just a CMF times that observed crash history. It doesn't take into account a lot of things like regression to the mean, variations in any of the parameters. It is just, well, here's what the history was, and here's what the improvement we think is going to do, and we're going to put that together. And for Wisconsin, we use a Excel spreadsheet to perform this method, which is primarily used for our vulnerable road user improvement projects. And that's because the HSM methodology, and by extension, IHSDM, is, I would say, a little bit weaker in predicting pedestrian and bicycle number of crashes, volumes, etc. So the IHSDM tool we found isn't as good for our needs when we're looking at making improvements for those vulnerable road users. Methods 2 and 3, we use IHSDM for. We usually build different models. Both of them use the safety performance functions from the HSM. Wisconsin, as Dan had mentioned earlier, we've calibrated most of the segment and intersection SPFs. We're actually still using version 16.0, which is the second to most recent update, I guess. The latest version of IHSDM is actually version 17. And in there, they added additional intersection SPFs, which we haven't calibrated. So to make it a little bit easier on our engineers, we didn't want them looking at calibrated models against uncalibrated models. So we haven't gone to version 17 yet. Overall, I would say our method 2 is the most commonly used one that is applied to most of our projects. And I'll get into an example that kind of shows why that is the most commonly used method at WSDOT, which I think is on the next slide there. So to walk through a couple of examples, Dan kind of mentioned we would go through and identify a location. In this case, let's say it's a rural 4-leg 2-way stop controlled intersection. We noticed a high number of crashes. We might want to look at realigning the roadway if it was a skew angle issue. We might want to add in left turn lanes. Some different things that we can do, as well as always comparing back to that, replacing in kind, a future no build, just as a baseline, so we have something for our alternatives to get compared back to. So in this case right here, we would use method 3, which is empirical Bayes methodology being incorporated. So we can utilize that crash history since we're not really changing too much about this location with our alternatives. We're not changing control type, we're not adding lanes, we're not adjusting the facility type. So none of those really major improvements. So the crash history that occurred before is still applicable to what we're looking at for our alternatives. So we would run that analysis and then again, using method 3, but let's say we wanted to consider a different alternative as well. So in our example 2, we would have the same kind of setup as this. Dan, I don't know if you want to go ahead and advance to the next slide. Awesome. So in this second example, we're taking that same location. First set of alternatives are the same, but maybe the number of crashes and the crash pattern were high enough or severe enough that we also wanted to consider replacing it with a single lane roundabout. Well, now the HSM says that we want to make sure that we're using the same methodology across all the alternatives that we compare. But since we're changing control type, we're doing one of those major improvements with replacing the 2-way stop with a roundabout. We can no longer use that observed crash history. So we're now back to method 2, or just the SPF, so that safety performance function predicting the number of crashes. Why that's really important is because when we use method 2, we're only looking at what that model, what that function says. We're no longer using the observed crashes that I would say additional information of location-specific issues, which can be a little bit blurry on exactly what is causing those issues, but those aren't being captured in this new model. So this is one of the reasons why methodology 2 is the most commonly used one, is because a lot of our projects, if they get to this point, we are looking at adjusting that traffic control, whether that's going from a stop control to a roundabout or a signal, or reconfiguring the roadway. Any of those major changes, we need to go back and just use that SPF. Dan, if you want to go ahead and advance. Which leads me into one of the main challenges that we're currently facing in Wisconsin, as we've kind of done this for a little over 4 years now, where we've had pretty good results of our regions and safety engineers going through and doing a number of projects. Dan talked about how we identify locations through our network screening. We specifically choose locations that are, we call them flagged, but again, if we think about that level of service of safety curve, that LOSS, category 4, those are, above what our function is showing. They are performing worse than an average location of a similar type. And when we use methodology 2, right, that most common methodology for us of using only that SPF, we're now saying that location that has crash histories and are being identified for being worse than the average, we're now applying a methodology that analyzes it as if it were an average location. We've really found that the biggest impacts in this analysis is primarily for our intersections, specifically roundabouts. And if folks have questions on more details, I can get into it, but it's something that we're working through. The HSM pooled fund study actually has been really great, and they've been looking into this topic and just released some research not too long ago. So that's something I'm going to be diving into and digging up and seeing how that might impact us moving forward. Which kind of goes jumping down there of incorporating new research is one of the things that it's just a continual thing that we have to make sure that we're paying attention to, figuring out what the best way of implementing it, rolling it out to all of our users is, and seeing if it's a good time to make a change. Like Dan showed very early on, there's been a number of changes throughout the years, and we're trying to be conscious of making too many changes too fast makes it hard for our analysts to keep up to date and feel like they have a good sense of what's going on. So we're trying to be strategic with how frequently we're making those updates. The other, I would say, main challenge that we see is surrounding the benefit cost ratio. I think it's a great value. It is something that folks who make decisions really, really like. It gives them a number that they can gravitate towards and be able to compare pretty easily across different project alternatives. The potential downfall of having this one number is if you don't properly convey all the different assumptions and limitations and the hidden factors that kind of boil down to get this one number, it can be very easy to pick a number that is high, but not necessarily impactful. And what I mean by that is we will do low cost treatments, which will have a very high benefit cost ratio value, which is great if we are looking to do something that is a little bit quicker. We want to make sure that we are still addressing an issue, but not necessarily have the time or the funds dedicated to be able to spend and do a reconstruction. But then something like a roundabout or roadway realignment, those benefit costs might not have the same value, right? It might be closer to 1 or might even be lower than 1. But the actual impact that it's making to the safety, right? If we're thinking about Vision Zero and what we're trying to do to drive down those fatal and injury crashes, that project, while might have a lower benefit cost value, could actually do more to drive home the point of moving the needle on reducing the number of fatal and injury crashes. And one of the areas that this really kind of gets complicated is when we have these unique projects. The HSM and all the SPFs and everything that are built and are running our analysis are from having a lot of data points of similar locations. So anytime we get something that is new, a little bit unique, something that doesn't fit that typical mold, we have to do a little bit more. We have to use our engineering judgment. We have to see, okay, what is the best case scenario for us to apply? And oftentimes that requires more work. A lot of it is looking at the same location and maybe using multiple SPFs, or looking at it with and without crash history to get more of a range that we're comfortable around, and saying, this one methodology can't handle it alone, so we applied a few, and we think it's in this area. So when that happens, it's really hard to, again, boil it down to just one benefit cost number. So those are some of the challenges that we've been seeing in Wisconsin. But the good news is we've also seen a lot of successes. Because of us being able to quantify a vast majority of our projects, we do get people throughout the department, the designers, planners, engineers. They understand that everything that we do has a safety impact, and they're asking the questions of, well, what's going to change? How will this affect the safety? Does it make sense to make a change here, or should we spend our money elsewhere? And being able to quantify this helps prioritize different projects, making sure that we're informed with our decisions and making good investments. So it's honestly been really great to hear a lot of the different folks that didn't handle safety on a day-to-day basis get the point of, yes, we can do safety and it can be quantified. Another note for us is that, before we had a lot of different program areas looking at making improvements to safety, but we are all doing things slightly differently. So now that we have a more established process, everybody kind of goes to that one. We're using the same crash cost values. So just all across the board, things are getting more consistent, which has been really, really helpful, especially when we're trying to compare different projects to one another. And then lastly, one of the things that we're trying to do in Wisconsin, and there's been a bigger push, is to do more with our local partners. And so we haven't done anything with it, or I shouldn't say anything. We've done a few steps, but now the groundwork is really being laid for us to expand kind of our capabilities, reach out to our local partners, be able to kind of go through the screening process and show them where we can make more improvements and help them quantify it, their safety impacts as well, instead of just, oh yeah, doing the standards will improve safety. So looking forward to what we have going on in the future. And on this last slide is our contact information. So if you have any questions and want to reach out to us, feel free to email. I'm going to turn it back over now to Greg.
Awesome. Thanks, Kevin. Thanks, Kevin. Thanks, Dan. Fantastic information. It's always, we always appreciate it when everyone's willing to share their challenges as well as the successes. I know it kind of puts you in a vulnerable position, but that's where we can all learn from each other. So thank you so much for kind of helping us understand your journey and how you guys got where you are. Before we kick it over to Danny really quick, we did have a question that I just wanted to see if you guys would be willing to answer really quick. Someone asked, what advantages does loss provide that critical rates, et cetera, do not? Are there trade-offs? So that's kind of going back and talking about, your site selection during the network screening process. So I'm not sure, Kevin, Dan, if one of you guys wants to take a swing at that answer.
I can give a quick answer.
Sure.
One of the really great things that we found through this methodology is that we can hone in on which, again, percentage we want to target. So we're trying to keep in mind the workload that we have with how much funding we have available. And we can do that, again, for the different facility types, for all crashes, for those fatal and injury crashes. So there's it gives us a lot of metrics to be able to do. And then it also says when we pair it with the potential for safety improvement, and we can add in crash cost values to those, we can get a good sense of, okay, this is performing this much worse than what would be expected. So we can see general improvement or potential for safety improvement of, X dollars. So a great way to get a lot of information just from a couple of metrics.
Yeah, I like that. No, great, Kevin. Thanks. It's there's always trade-offs, right? No matter which performance measure you ultimately land on, you're always going to have a trade-offs. But I love that explanation. You get a real good snapshot. PSI is a real powerful performance measure in itself, and loss gives you a good lens to kind of select a section of that population rather than getting hung up in the individual number. So yeah, great explanation. Thank you. And great question as well. Thanks for that. We've got a couple more questions, but we're going to circle back and answer those after we kick it over to Danny Anderson to talk a little bit more about alternative design. So keep the questions coming as you drop them in the Q&A. We'll make sure that we answer them at the end. So Danny?
Yeah, thank you. I think you can obviously tell after that presentation what a wealth of knowledge Dan and Kevin both are. And so as we started going down this path, their help has been invaluable. And so I'm glad that we were able to connect early in this process. As well as before we jump into this, we've worked with about 10 other states on this project. So this has not been done in isolation. This has been with the help of both safety engineers and geometric designers and conceptual designers from 10 different states. And so, but I really appreciate the help that Kevin and Dan have given us and setting us up for this conversation. So, as it suggests, Part-C tool to help designers easily consider safety. Obviously, safety engineers will also be using this tool, but we'll get into why we specifically call out designers. Okay, this is what we're going to go over: the growing priorities in design, the current tools and scenarios, and then we're going to go do an overview of the brand new tool, Alternative Design, the AASHTO Safety tool. So the growing priorities in design, a lot of them have to do with safety, and there's more money being put towards safety now than ever before. So it would make sense that that would start becoming more and more people's responsibility, and designers are feeling this as much as anybody. But you have things like safe system approach, the growing requirements. We have a couple of questions on VRU that we'll come back to in the Q&A, but VRU is also obviously a big thing. You have the standards and the staples like design exceptions and potentially those increasing costs of projects and requiring design exceptions. Then you have quantitative reports and increasing amounts of potentially federal requirements, helping understand the safety impact, and the Green Book Volume 8, which will increase the importance of quantitative analysis. So for designers, there is a lot happening with regard to safety. And the current tools that people have to use, Wisconsin already talked about, that they rely on the IHSDM for that third type of analysis. There's the FHWA has spreadsheets, consultants have made spreadsheets, and there's a lot of consultants who do these kind of calculations manually. And they're all good. We don't have anything negative to say about any of them. Like, a lot of people have put a lot of good work into this. But we'll talk about what we heard and the feedback from the community as we were looking to help unite the designers and the safety engineers on this. So for the new tool, the usability issues that we really sought to work on were inputting data manually was the most consuming part of the process. We heard that it was taking between 80 and 90% of the time was just getting the data into a way that it could be analyzed. And so that shouldn't be a shock to anybody. Data is hard. So that was our first hurdle. Second one is designers want to immediately understand the impact of their changes. When they're working on a project, they don't want to have to get through everything, hit a button, come back 10 minutes later and see a number and then not understand, okay, I don't know how this impacted it. So we wanted to provide designers with immediate understanding of what changes when they make certain design decisions. Also, kind of going right along with that, the ability to analyze multiple proposals at the same time is table stakes. Like, we need to be able to compare things and understand very quickly how different decisions impact outcomes. And then, and I've alluded to this, but this needs to be created for designers, not for safety engineers. Safety engineers definitely will use this, but as Dan pointed out, this happens in the project scoping. And as we've spoken with those 10 plus states, where we found that this tool is needed is in the conceptual design phase, when we're just trying to understand what are we even looking at. But if we already have a design and then we try to include safety, there's a good chance that we can't do it because we're too far down the path. But if we can do it early enough that it's in the concept design and we understand the value of what we're doing, we have a very good chance to not only increase safety, but put the money where the best results will end up. So why a new tool? So the IHSDM, which Wisconsin has been using, has been sunset. And so there is a need for a new tool to help them bridge that. To be clear, like the HSM Part-C is good, but it has struggled to be adopted nationwide. And as we consider the HSM2, it's going to become more complex. So we have something that did not take root as much as we hoped it would. And we want to make sure with this next iteration of the HSM, there's so much hard work and good work being done by so many people. We want to make sure that this is accessible as possible, and that we can use those findings to make our roadways as safe as possible. Green Book Volume 8 will increase the need to show quantitative data showing the impact of safety in designs. And so both the safety group is getting an update to their manual, and the geometric design group is also getting an update, both of which really are relying more heavily on quantitative data. So ensuring that there's a tool that helps both groups out is huge. And I already talked about anybody using the IHSDM tool are going to be needing a replacement soon. So we're going to jump into the tool. We're going to talk about a couple of things, but here's a couple of scenarios that are real, and they've already been brought up by Dan and Kevin. You have the potential for just ongoing projects where maintenance or rehabilitation needs to go out and work on a project. You also have those projects that network screening has identified, and you know that there is area where you should be able to improve it. So we'll jump into the tool now and look at what we can do. I'm going to jump into the first one is like we talked about. All right, sorry. Okay. Let me make sure that I'm in the right place. I believe I am. No, let me back out real quickly. I hit my computer at the wrong time. So this is an example of, and we heard this from a couple of the southern states we worked with, especially, who deal a lot with bridges. They're told that when they go to do a bridge maintenance project or any work on a bridge, that they need to bring the roadways entering and exiting the bridges up to design standards. And so they need to understand what is the impact of bringing a 10-foot bridge, a bridge that has 10-foot lanes, and creating 12-foot lanes for the roads up to the bridge and leaving the bridge. And so this helps you. So we went in and we're going to work on these two bridges right here going over this. So we have a couple of different segments of roadway that we'd be working on. So the first thing I do is I just go in and I create the segments, and that's very easy. I can just add a segment by popping this up. It shows the whole LRS, and I can create a segment of roadway, and this is what we're going to work on. If I ever do one incorrectly, just remove it and get rid of it. now that I have the definition of the areas of the road I'm going to work on, the next thing I do is I go into my current conditions. And so the first thing it's going to say is, do you want to name this? We'll call it Upper Walton. Roadway type. So the current roadway types we have in here are rural and urban suburban arterial, and we'll have interstate in soon. We automatically pull in the ADT from the state's data, and we calculate the length and everything else. So this is the overall information of the first portion. Then we go through and we put the roadway details in. So I know that this is a 10-foot lane width, and then I know my shoulders are 8 feet and they're turf, and I start adding them. And what you can see right away is there is this adjustment factor. And if anybody doesn't know what an adjustment factor is, it's what CMFs in Part C will be called when HSM2 comes out, the adjustment factors. So they're calibrated to specific SPFs. And this starts showing me right away what things are going to be driving more crashes and what will be reducing crashes. So for each roadway, I would go in and I would put everything about this roadway into this section, including if there's passing lanes, two-way left turns, segments. And I'm only presented with the information that I need specific to the roadway type that I chose. So since I chose rural 2-lane, I only see the pieces I need for rural 2-lane. Now we do have a portion built in that we will be putting in the bike ped that's coming out with HSM2. It's already stubbed out, so we'll have that soon. But this will go through and it'll actually give me my crash history now. In this area, there just haven't been crashes. And so you're not going to see anything. It's not too exciting. But in brighter news, there haven't been any crashes. Isn't that awesome? What I'll do is I'll go and do the same thing for all three, for Middle Walton, Upper Walton, and Lower Walton. And this will say exactly what the roadway looks like right now. Then what I'll do is I'll come into the no build and say, if we don't build anything, what's going to happen? So I'm going to include an ADT growth. So I'm going to say over the next 10 years, which would also be the scope of our project, I'm going to have a 3.5% growth rate. And then in cost, this is something that Wisconsin specifically called out, is a lot of times we're going out to do a project anyway here. And so we want to include the project cost that's going to be associated with this, even if we don't add safety improvements to it. What's the project cost? And so that's what can be built in here. So it's going to continue, and this is going to give me my number of crashes by expected number of crashes over the next by segment. And so we have that in our back pocket. The next thing I'll do is I'll add a proposal. Because of time constraints, I just did this beforehand. But Upper Walton, so what we do is we say, okay, we need to take this from a 10-foot shoulder width to a 12-foot shoulder width. As I change this, you see the graphic on the side update so that you can see the blue means this is actively different. The other cool thing is it calls out right here, we are proposing that crashes, with this change, we would see crashes going down. So if we then just took those 2 feet away from the lane width, add them to the lane width and took them from the shoulder width, but paved the shoulders, we can come in and say, this is going from an 8-foot shoulder width to a 6-foot shoulder width. And we're going to pave them where they used to be turf. And I have all that information right there. So that's all I'm going to do. I'm not going to change anything else. And I'm going to do the exact same thing to all three. What I'm going to go in and do is I'm going to say this is the lane width is going to cost about $450,000. And paving the shoulders is going to be about another $200,000. And what I'm starting to get here are my total benefits, severity of crashes and crash costs, as well as the project's cost, giving me my benefit cost ratio. And this goes through and starts showing me this is the no build, this is if we make these changes, right? I'm going to do a second one, and this time all I'm going to change is the lighting. So if we were just to add lighting along all of these roadways, where there weren't lighting before, and we put in a cost of about $300,000, we have our crashes that have gone down. Sorry, I missed this. It's about $300,000 and it's about $970,000 of benefits. So we see a BC ratio of about 323. And then I'll just do one last one, which is, let's take those 12-foot shoulders, reduce the lanes to 6, but let's keep the turf, as well as let's add lighting. And so we're going to do all 3 of these proposals, and we'll add the cost. And so we see the total benefit, the project's cost, and that the total benefit cost ratio. And we have that comparison summary now. Now I can look at all 3 of these proposals, including the no build. So really 4 proposals in the same area to see what is the benefit. And if we would have had a cost for the project, we would have a benefit cost as well for the no build. But as well as what kind of crashes are being reduced from a severity standpoint and how many. And I can start seeing which project is going to give me the best benefit cost ratio, as well as, and Kevin alluded to this, yeah, but which one's going to actually help safety the most? And so you can start having those conversations. And so this is an example of one that has a relatively low number of crashes. Let's do a different one that has a higher number of crashes. So this is just south of Tennessee up in Georgia, once again on a rural 2-lane road. And I've gone through and we have an intersection, a segment, an intersection, and a segment. And we have all of our current conditions set. We won't go through all that again, but we will do the lighting. And so we're going to do intersection lighting on the intersections and segment lighting on the segments. And we're going to do this for all 4 of them. And then we're going to do a cost. And for the intersection lighting, we can show it's going to be about $150,000, and for segments about $200,000. And now we can see, because of the number of crashes that are occurring on this roadway, our benefit cost ratio is much higher, just because there are so many crashes predicted and expected to be there over the next 10 years. So I have a lighting proposal. We're going to do the same thing. Let's move this to no changes to the intersections at all. But let's make the road lane width 12 and the shoulders 2 feet from the shoulders. So we know that that's going to go up, but we also know that the lane width is going to help with crashes in this area. And those are the only changes we're going to make on this segment of the roadway. So nothing to the intersection once again, but once again for the low burning bush, we'll do the same change. So the crash cost, or sorry, the cost for this is about $400,000 for the lane widening. And that gets us our benefit cost ratio of about 4.08. So let's do one more, which is a combination of the 2. We're going to put lights in. And then for the roadways, we're going to widen that lane to 12. We are going to reduce the shoulder width to 4. And then potentially we're going to put lighting in on the segments as well. So once again, lighting at all intersections and on the segments, and then the lane widths improved on the segments. We'll go and put our crash costs in here. So we have $150,000 per intersection lighting, lane width of $400,000. Shoulders is built in with the other, and then $200,000. So about $750,000. So once again, we have a benefit cost ratio of about 6.76. And here's another good example of making decisions. You could be going with the highest benefit cost ratio, which is going to be something closer to about 8.39. Or you can be looking at what is going to be reducing the most crashes, especially when you talk about the severe and fatal injury crashes, because your difference is a return of investment of, you get about $5.1 million in benefits, but it's only a 6.82 benefit cost ratio. So these are the things, and going back to Kevin's conversation of the cool thing about having a tool that the design team and the safety team and other teams, the planning team, can use throughout the entire agency. And as probably most of you know, AASHTO Air Safety is a single license that the state can then share to everybody. So we don't want anyone not using this, because there is such a big deal with alignment and being able to have everybody using the same numbers and looking at the same data so that decisions across agencies are easier and easier. And so being able to look at this and have those conversations quickly is the point of this. So this alternative design tool is going to be going out with the AASHTO catalog July 1st. Well, it opens July 1st. I think the catalog goes out first week of May. And it will be there for anybody who wants to start using it. We're very excited about it. We're very excited that this has not been an AASHTO project. This has been a safety industry project, including a lot of designers. As like I said, we've had over 10 states helping give feedback, providing language updates, providing requests, and we're getting a lot of good momentum based on that. So with that, I'll turn it back over to Greg.
Awesome. Thanks, Danny. So I know we are at time. We're going to be sensitive of everyone's time. The questions that came through the Q&A window, Dan and Kevin were kind enough to go in and drop some answers in there. So if you asked a question, hop in there and check out that answer. If not, if you haven't had a chance to read through those, there's some great responses in there, a lot of great questions and a lot of great dialogue going on. Those questions will be included in the recording that we're sending over as well. So if you want to catch up on those, you should get that email a little bit later. Big thanks one more time to Dan and Kevin. Thank you so much for taking the time out of your day and your schedules to come meet with us and to share what you guys are doing to make roads safer in Wisconsin. So thanks again as well to Danny for taking the time to walk us through that new alternative design application. We do have our next webinar on the books. Let's find my slide. So we do have our next webinar is right now, I believe, roughly scheduled for August of 2024. We're going to be taking a look at Part B network screening a little bit closer. Specifically looking at how the Ohio Department of Transportation is using predictive analytics in network screening. So look for the invite for that one coming out in the future as well. In the meantime, thank you everyone for taking the time to join us today. And thanks to all of our presenters. Stay safe, everyone. Have a good day.